Students, today we will obtain the reduction formula of sine raised to the power nx, and hence we evaluate sine cube x dx. In order to obtain the reduction formula of sine raised to the power nx, consider in sine raised to the power nx dx. Call this equation number 1, and now split sine raised to the power nx into two parts, sine raised to the power n minus 1x into sine x. Call it first function and its second function. Using integrating by parts on this integral, we get sine raised to the power n minus 1x integral of sine x dx minus derivative of sine raised to the power n minus 1x integral of sine x whole integral. Now integral of sine x is minus cos x, so first term will become minus sine raised to the power n minus 1x into cos x minus sine raised to the power n minus 1x has derivative n minus 1 into sine raised to the power n minus 2x, and after that derivative of sine x is here cos x, and integration of sine x is minus cos x dx. In next step we combine this minus with this, and this will become the positive sign, and minus 1 is a constant, that means it is independent of x, so we will take it outside from the integral. So in integral we have two terms, sine raised to the power n minus 2x and cos square x dx. In next step we will substitute the value of cos square x, which is 1 minus sine square x, and in another next step we will multiply sine raised to the power n minus 2x into this bracket 1 minus sine square x. So this integral will split into two parts. The first integral will be sine raised to the power n minus 2x dx, and next will be plus minus minus n minus 1 sine raised to the power nx dx. Now left hand side is in, right hand side will be minus sine raised to the power n minus 1x cos x plus n minus 1 into in minus 2. It is nothing but replace n by n minus 2 in equation number 1, and this last integral will be in again. Now take this term to the left hand side, we will get n in is equal to minus sine raised to the power n minus 1x into cos x plus n minus 1 I raised to in minus 2. Now divide both side by n, therefore the value of in will be this thing, that is the equation number 2. Now we want to calculate the value of sine cube x dx, that means we have to substitute in is equal to 3 in equation number 2. When we substitute n is equal to 3, we will get minus 1 by 3 sine raised to the power 3 minus 1 sine raised to the power 3 minus 1x into cos x plus 3 minus 1 by 3 3 minus 2. So this will be this thing. Now you have to calculate the value of I1, and the value of I1 will get by putting n is equal to 1 in the beginning of this equation. That means in the equation number 1, this will be integral of sine x dx, which is minus cos x. Substitute the value of I1 here, you will get the value of I3. Now moving to next question. In next question we have to calculate the in, where in is 0 to pi by 4 tan raised to the power nx dx. If there is no limit, then also you can find out the value of in without substituting the limit, but there is a limit, so we have to use that, and we have to prove in plus in minus 2 is equal to 1 by n minus 1 if n is a positive real number greater than 1, and hence we have to calculate I5. Now consider in, which is 0 to pi by 4 tan raised to the power nx dx. Call this equation star. As we didn't have any formula for tan x, but we have the formula for tan square x in terms of secant square x, so we'll split this n into n minus 2 into 2. That means we split tan raised to the power nx into the product of two functions, tan raised to the power n minus 2x into tan square x. Now in next term we will substitute the value of tan square x, which is secant square x minus 1. Now multiply this tan raised to the power n minus 2 by secant square x, we will get this, and by 1 we get this. Now split this integral into two integrations by splitting the limits. Now this is in minus 2, it is nothing but the equation star by substituting n in place of n minus 2, and in order to solve the first integral In order to solve the first integral, we will put tan x is equal to t, so secant square x dx is equal to dt. That means this thing is dt, but we have to change the limit also. So put x is equal to 0. When x is equal to 0, your t is equal to tan 0, which is again 0. When x is equal to pi by 4, your t is tan pi by 4, which is 1. So your limit will be 0 to 1. This I n minus 2 will goes to left hand side. So in left hand side we have I plus I n minus 2 is equal to 0 to 1 t raised to the power n minus 2 dt. The integral of t raised to the power n minus 2 is t raised to the power n minus 1 divided by n minus 1. Its limit is from 0 to 1. After substituting 1, it will be 1 upon n minus 1. So this is the result which we have to prove. Now we have to calculate I5. Substitute the value of n is equal to 5 here. We will get I5 plus I3 is equal to 1 by 4, and then again substitute n is equal to 3 because we need I3. Then I3 plus I1 is equal to half. Now we need I1 we will get from the equation number star. Your I1 will be 0 to pi by 4 tan x dx. Integral of tan x is minus log cos x, limit 0 to pi by 4. This will be log cos pi by 4 minus log cos 0. Cos 0 is 1, so log 1 is 0. We will get minus log 1 by under root 2. We will write 1 by under root 2 means 1 by 2 raised to the power half. Now log m raised to the power n is equal to n log m, so minus half आगे आ जाएगा n log 1 by 2. So this will be minus 1 by 2 log 2 because log 1 by m is equal to minus log m. Now substitute the value of I1 here, we will get I3, and value of I3 here we will get I5. Thank you.